Hello everyone, I am Roberto Perez. I will be presenting the Ethernet, discussing what it is and how it works. Please follow along with the PowerPoint that I have posted in the discussion board. I won't be able to show it through the camera because the screen is too bright and it will make the camera not work. So just please pull the PowerPoint and follow along. I will let you know which slide I will be discussing as I'm going. So I'll get started right away. The Ethernet. Yeah, Ethernet is a local area network technology. It was developed by a gentleman called Bob McAuliffe in 1973. He was a Xerox researcher that worked at the Palo Alto's research center for Xerox. He was working on a way to connect the Xerox Alto computer to a printer. McAuliffe came up with the physical cabling requirements as well as the standards for the actual implementation of the cables. When the Ethernet was first implemented by McAuliffe, the way it worked, it was a single cable shared by all devices on the network was used. Thus, it allowed the attached devices to communicate with each other, and this also made the connection scalable, since adding new devices to the connection did not require current devices to be changed or modified. The Ethernet is based on protocols. That is the backbone. These rules are what tell the connected devices how to communicate. In order for the connection to work, all the involved devices must understand and implement the Ethernet's protocols. The basic Ethernet terminology consists of mediums, segments, nodes, and frames. The medium is basically the physical cabling required for the Ethernet to work. It used to be coaxial copper cabling, but today it consists of twisted pair cabling and fiber optic cabling. A segment refers to a single shared medium. Nodes are the devices that are attached to the segment, and frames are the messages being sent between the nodes. In a way, frames are how the devices are connected in an Ethernet network. The frames are how the devices, that are connected in an Ethernet network communicate. The protocols provide a set of guidelines that must be followed by all devices or nodes when creating these messages, and that these frames must have a specific minimum and maximum length. Basically, and some of the information that must be included in these frames consists of a source address indicating where the message is coming from, and a destination address stating where the message has to be sent. The source address and destination address will uniquely identify a node or device, and not two Ethernet devices should ever have the same address. The way the Ethernet connection is set up, it enables a sent signal to reach every single attached device. This makes the destination address a critical part of the equation for a successful Ethernet connection. The destination address will specifically indicate who the recipient of the message or frame is, and when the message is sent. Please follow along. We're at the slide that's titled Ethernet Protocol, and so just make sure you're in the right slide. Like I was saying, the destination address will specifically indicate who the recipient of the message or frame is. So when a message is sent, this is a very important concept, it will be received by every device in the network. Each device will check the destination address to see if the message is sent it's meant for itself, and only the device with the destination address that matches the message's destination address will examine the content. And all other devices will just check the address and discard the message. The only exception to this rule is if the message contains a broadcast address, in which case every device attached to the segment will receive the message and check the address and review its contents. The other very important aspect of the Ethernet protocol is the concept of CSMACD, which is a acronym that stands for Carrier Sense Multiple Access with Collision Detection, and it describes how communications are regulated within an Ethernet connection. Okay. Please go to the next slide. Title CSMACD. The carrier sense part of the protocol, it basically states that every device must listen to the medium and make sure that there's no other transmission going on before they can attempt to transmit a signal. The multiple access part, just like I just mentioned, basically states that when one transmission is sent, every single device in the medium will receive the transmission, check its address, and if the destination address matches their address, it will check the contents. Otherwise, it will just discard the message. The collision detection portion of the protocol basically states that devices will not no devices can transmit at the same time. And the way this is achieved is when a device will sense that a collision is about to happen, so it will stop its transmission, and it will wait a random amount of time to make another attempt to send its signal. Now, waiting a random amount of time is it's a very important part, because without it, the devices will try to send a signal. They will see that the medium it's busy right now, something is transmitting, so as soon as that transmission is over, they will attempt to transmit again, and they will collide again and again and again, and it will just create this infinite loop, and it will not be very efficient. So the random aspect is very important for this. Okay, please go to the next slide. Basically, I'll discuss the limitations of the Ethernet. The two biggest ones being the length of the shared cable and the amount of devices that can coexist within a shared cable. The length of the cable, it can't be stretched too long, because the quality of the electrical signals decreases the longer they have to travel. And also, there are several exterior factors that could affect the quality of the electrical signal, such as interference from other electrical devices and so on. For this reason, the Ethernet cable must be short enough for the electrical signals to travel clearly and without delay from one connected device to another. The other obvious limitation is that because of the Ethernet's CSMA-CD protocol, only one device can transmit a signal at a given time. This protocol works great when there are only a few devices attached to the network, but companies and businesses in today's industry, they have a lot of devices within close proximity, which is not ideal if the Ethernet connection still work this way. As more devices are attached to the network, the medium will become saturated, and even with the random delay, the devices will have to wait an acceptable amount of time before they can transmit their signal. This will make the connection slow and unreliable, which will kind of defeats the purpose of using a local area network technology to connect devices. Fortunately, engineers and developers, they came up with several devices to relieve both the cable distance limitation and increase the number of devices that can be connected to an Ethernet connection. This leads to the next slide, basically the solutions. So the first device that they came up with was called the repeater, and it increased the network diameter of the Ethernet connection. The device, it connected multiple Ethernet segments. The device would listen to a segment and transmit its signal to every other segment that was connected to the repeater. The device did wonders for increasing the length of the shared cable, but it still did not address the fact that segments will become congested even if they were linked with repeaters. As the number of connected devices increased within a segment, the number of transmissions would increase as well, and the number of collisions and the connection would become inefficient and ineffective. So engineers realized that the only way to reduce this congestion problems was through the use of multiple segments. A single segment will be divided, and it will create multiple collision domains. Now, these multiple segments solve the congestion problem, but it did not address how segments were to communicate with each other. And this is where bridges came along. Bridges were devices that brought the best of both worlds as far as increasing the diameter of a network, handling the congestion problems, and solving the segmentation issue. A bridge would connect two or more segments just like a repeater would, thus increasing the length of the Ethernet connection, and act as a traffic regulator. The bridge functions just like any other device connected to the medium. It can receive and send signals with the exception that it cannot create any traffic of its own. It can only echo what it receives from other devices connected to the network. A bridge, it uses the multiple access and shared medium nature of the Ethernet connection, in order to relay traffic between segments. The main goal of the bridge was to reduce unnecessary traffic on the connected segments, and the way it does this is by inspecting the address of a received message and determining in which segment the destination device is located, thus forwarding the message only to that specific segment, liberating the other segments from unnecessary traffic. Just a quick example. If you have if a bridge is connecting as two segments, you have segment A and segment B. Now a device in segment A is trying to send a message, send a frame to a device in segment B. So what the bridge would do is will receive the message, the signal, and it will transmit it It will receive the signal from segment A and it will transmit it to segment B in order for the frame to reach its destination. Now, if a device within segment A is trying to reach the other device with segment A, the bridge would would realize this, and so it will not forward the message to the other segment B, and this will also allow the two devices within segment B to communicate at the same time as the device in segment A, which is kind of nice. And basically, the repeaters and bridges, they eventually led to the modern Ethernet. So if you could please go to the next slide, titled Modern Ethernet. And yeah, I'll go ahead. We got the switch Ethernet, which is basically this is the functionality of bridges is being used. It's just that the main difference is that the switches offer a dedicated segment for every device in the network. Additionally, with legacy Ethernet connections, they used long runs of coaxial cable to connect the stations. Modern Ethernet networks use twisted pair wiring. Basically, switch networks provide each device with a dedicated segment that is connected to a switch, and these switches act as bridges, but they can connect to multiple segments at a time. Each segment within a modern Ethernet network connects only two devices and the switch and the end station. So the switch picks up and examines every transmission, then it forwards it to the appropriate end station. Thus, it eliminates unnecessary traffic and allows multiple transmissions to be sent and received simultaneously. The other major advancement was the full duplex Ethernet. In legacy Ethernet, devices could only could either be sending a transmission or receiving a transmission, but they could not be doing both. Now, modern Ethernet, they fiber optic or twisted pair cabling use separate conductors for sending and receiving data, which makes the connection full duplex. They could be doing both at the same time. Only this. Additionally, the stations only communicate with the switches and never directly with each other, which allows the devices in the network to carry out the collision detection process and transmit data at will. Okay. Now the Ethernet. There's two alternatives. There's other two major network technologies that could be used. One of them is IBM's token ring. The other one is the asynchronous transfer mode network. The way these other two technologies work is the token ring applies a strict orderly method to regulate access to the medium. Basically, it organizes devices in a logical ring, and it creates a special frame called a token, which permits devices to transmit a signal in one direction. The token frame will circle the ring until it is captured by a device that wants to transmit a signal. The device will then replace the token frame with the data carrying frame and send it around the ring. And then once the data carrying frame returns to the device that sent it, the device that is meant to, the device will replace the data carrying frame with a token frame, which will circle the ring again until another device wants to transmit the signal. The token ring devices do not consider the carrier signal or collisions because of the nature of the token ring frame. So, and the other one is the synchronous transfer mode network. They're considered to be in between, a local area network technology and a wide area network technology, because they allow several devices far distances apart to be connected, and they're reliable and they have good speed, and they allow the transfer of not only data but also video and voice traffic. But which makes the ATM networks versatile and expandable. But the technology hasn't quite gained the acceptance needed to make it to the top of the network. To be a top network connection choice. This is where the Ethernet kind of has its reign. It's been it has over 30 years of industry acceptance. It is well known and well understood, which makes troubleshooting and configuration easier than the other technologies available. The Ethernet has also evolved and changed, and it has become faster and more functional in order to keep pace with other network technologies. As a result, it's continued to be one of the most popular network technologies in the industry. Hope you enjoyed it.